Welcome
Cool.
back to Consilience Conversations, episode 5, and back with me is Dr. Matt Roos. Welcome back, Matt.
Hey, Alex. Good to be here, as always.
It's good to have you. And so, as usual, we prepared a little before this, and like we did last time, I'm about to share the sort of rap sheet we're going to go off of, the sort of, basis for our conversation. And so what we did
may or may not follow too tightly.
Right.
See how it goes.
And excuse me, and I'm sorry my voice is sort of gone, but I've been lecturing hard this week and I've been putting a lot of content down, so it's worth it. It's fun. And so today we read a pretty, I would say, technically difficult paper called, what was it called? The Basal Ganglia and the Amygdala, something by Jeffrey Gray, something like that.
Yeah, it's a sort of an older summary paper of different systems or nuclei, that is basal ganglia, nuclei, and beyond in the subcortical areas of the brain. And it's just for the listeners' awareness. It's an older summary, so there's a lot of newer, more nuanced material in the neuroscience community that one could pick up on. But nonetheless, it still does a first order decent job of summarizing some things.
Yeah, and so something I was really interested in talking to you about, which we could make a pretty good literary connection to in Dante's Purgatorio, was sort of the connection between these systems and the release of dopamine, or the reward neurotransmitter that makes you feel like elation and joy, and how that relates to the development of habits, and also what you mentioned below, how that could also potentially lead to like bad habits, like addiction.
Absolutely. Yep. And we'll get into it, but we should, at some point through this discussion, we'll sort of like delineate a little bit about sort of reward and pleasure. These aren't really the same things. And so a lot of times the media portrays it as if dopamine makes you feel pleasure, like you would for certain drugs, but that's not really the case. And we can talk about that.
Yeah, well, I'd like to hear a little bit about that demarcation, or that differentiation between pleasure and reward, and what dopamine actually does, because my understanding is fairly simplistic like that, so I'd like it to be a little more nuanced.
Yeah, sure. So, as with all material that I discuss about in the neuroscience realm, take it with a little bit of a grain of salt. That sometimes these are complex and hard to explain, or even this neuroscientific community doesn't have a complete grasp of it. It's just there's a lot to learn still. But anyway, the important point here is that we've come to realize in more recent years that it's somewhat fair to say dopamine is sort of a reward-related signal, or it is a reward-related signal. And what it's related to is sort of the value of some outcome, of some action or behavior, or some explicit tangible reward you might get after performing some behavior, which it could be, of course, food or sex or something else. But it's not the dopamine itself that might make you feel that way. It's if we talk about, we often think about this, or people often discuss this in context of drug addictions, pharmaceutical or street drug addictions. And a lot of times it's not. So if you take something like an opioid, heroin, for example, it is the heroin that gives you the pleasure. And it's not the dopamine that gives you the pleasure. The heroin activates is other different types of neurotransmitters, and that activates sort of pleasure circuits in the brain.
Are those GABAergic ones? I wanted to ask about that too.
Did you say are they GABAergic?
Yes.
I think there's going to be a variety of them. And so, GABAergic cells are cells that have GABA receptors or emit GABA are GABAergic, but that doesn't really relate necessarily to what sort of opioid receptors those cells may have. So a single neuron can have receptors for, and does have receptors for, many different types of neurotransmitters. So we often talk about glutamatergic cells, which emit glutamate, and that excites other cells when it transmits to them. And you mentioned GABA, and that if the GABA is a neurotransmitter that typically inhibits neurons, that it passes on the GABA too. and that's not there's a little bit of variety there, but nonetheless, those are sort of like some of the dominant neurotransmitters especially in the cortex. But there are many other receptors, and we've already mentioned opioid receptors. There's receptors that are more or less responsive to all the types of drugs that someone would consume: alcohol, nicotine, amphetamines, etc. And dopamine receptors are at a lot of places there. So, but again, the real thing is there that the pleasure. Okay, I'll give you probably a more concrete example. And I don't know the details of these experiments. So there have been experiments with rats in which the rat is administered some sort of pharmaceutical which reduces or minimizes the impact of dopamine. So they may, be subjected to some sort of molecule that blocks the dopamine receptors from dopamine itself binding to those receptors. So the impact of dopamine is low compared to a regular state. And then they allow the animal to self-administer some sort of drug, so say an opioid drug. And that animal will, this rat will move around in the cage and hit some pedal, for example, and then it gets some nice free heroin. So what the rat does is it exhibits the behavior, all the behaviors, both its, seeking that heroin, as well as its physical response and behavior once it takes in that heroin. So it still gets all the pleasure from that heroin. But because the dopamine receptors are blocked, it's much less likely to become addicted to that heroin, or that is, not even necessarily addicted, but to continually go seeking that heroin down the road. Whereas if you don't block those dopamine receptors, the rats will get quickly addicted, and they will just self-administer to the point where they will, effectively kill themselves. So it's the dopamine that somehow signals to the system that I enjoyed this, and of course I'm anthropomorphizing the system, but the body enjoyed this. This was pleasurable. Therefore, I'm going to relate this substance to and value it as a reward, and I will go therefore seeking it. Or if I'm in a context, in a situation where I recognize that I can take action to obtain that heroin, opioid, whatever, then dopamine is released. It lets the animal know that this is there's something valuable present here, and I may want to go seek that out.
So that's interesting. Yeah.
Yeah.
That just makes me think that how you describe dopamine there is like the grease on the wheel, and that it just makes, with the presence of dopamine, the development of a habit or action pattern becomes, it makes that action pattern easier and easier to implement with less and less effort, is what it sounds like. Because
and so dopamine, it's also kind of difficult to talk about because it's multifaceted in some of the things it mediates in the brain. And so we just talked about that, where sort of it represents reward, or value is perhaps a better term, the value of taking some action or receiving some substance, physical or otherwise. But it also has a role in learning habits, as you will. So what we know most about basal ganglia and dopamine in the basal ganglia are related to motor, because partially because of the terrible neurological diseases that are related to that, like Parkinson's disease. So we know about if you lose that dopamine input to certain of the brains, you have motor problems. So it has some role in sort of just day-to-day behavior. So kind of jumping around here, but there's three things I would like to think about. One is what we mentioned about the reward representation. The other is about it may be more like selection of actions or initiation of actions. And we know of that particularly from disease like Parkinson's. And so that's a relationship of the basal ganglia and the dopamine system with motor regions of the brain. But a lot of people, it's the conventional wisdom is often to talk about 5 different loops between basal ganglia areas and other cortical areas. And so even though we know the most about the motor system and dopamine and basal ganglia connections there, it's likely that there's similar or parallel analogies that can be made with other areas, including frontal lobes for critical or thinking, cognitive tasks, limbic systems that are more sort of in the emotional space, and so forth. And then sort of finally, the last three of that triumvirate is simply learning. So as we learn, well, what is learning? So there are various forms of it, but a habit may be a learning of, again, going back to motor, and a sequence of actions that you might take. So when you're driving the car, you effortlessly navigate the wheel, work the pedals, and back in the day, work the stick shift. And those are sort of like motor behaviors that are so repeated so often. Early on, when you're trying to learn that, you have to think about them very consciously. And the dopamine is released as a reward. Again, that motor, that value. And that can modulate or like sort of open up the learning window and allow for strengthening or weakening of connections between other neurons that are important for that habit to form. But once that habit is formed, it's sort of like crystallized in some new neural circuitry or new connections between those neurons, or stronger connections. And now the dopamine is not necessary for that. That habit is just effectively initiated. It's now learned. And I guess the important part here is it becomes an easy task. You don't have to think about it very much. You do it. It doesn't take as many sort of frontal lobe or cortical resources to activate that habit.
And well, that's so interesting, because that makes me think two things. To one of your earlier points about the, what was it? Sorry, trying to keep two things in my mind at once, messing things up there. Oh, yes. What was the connection between goals and consciously set goals and consciously held values and pursuit of actions that represent those values dopaminergically? And how does that relate to the limbic system and the experience of negative emotion? Because my superficial understanding of that, and I'd like to know a little bit more about the limbic system. We were talking about that in the pre-show. And I guess is that it is responsible for negative emotion and becomes disinhibited when your vision of the future, specifically the hippocampus in that way, but maybe the amygdala too. I'd love to know more about both of them from you, and what the limbic system even means. Why is it called that? But how perceived or a predicted or a desired future does not come about, and then instead of getting reward, you get punishment from your subcortical circuitry.
Right. Yeah, and it could be that in some cases, a release from potential threat or something negative, of course, that also has value. That has that release from the potential negative has positive reward in a sense, or positive value associated with it. So I'm speculating here, but I don't. It may be that dopamine can still play a similar role in conditions or situations where you might want to avoid something. And you mentioned the amygdala. There's a lot of complexity there, but it's well known to be sort of an area that processes fear or danger, aversion. And so how that comes about is not clear. That is, how is it that the amygdala, how is it that neurons in the amygdala become active when you perceive a threat? And sometimes that may be a physical threat if you're out in the wilderness and mountain lion is in the distance, or perhaps you're giving a presentation and someone asks you a challenging question. So there's some sort of fear or anxiety there. But in any case, that certainly has its own sort of set of connections and neurotransmitters associated with it. How these pieces of the puzzle of the sort of broader limbic system fit together, I can't really speak to too much today. I will. It's funny that you mentioned that you asked, what does limbic even mean? And I don't know the answer to that certainly not from the standpoint. I should know it probably from the standpoint of what's the sort of Greek or Roman, Latin or Greek background from it. But modern day, some neuroscientists have stopped using that term or avoid using that term because of its sort of ambiguity and imprecision. And sometimes it's an umbrella term and that doesn't really do us any good. So I know you wanted to talk at some point down the road here today about Punksev's emotional states. And so, those might be more precise terms to discuss, and not lumping them all into something and calling it the limbic system may not be beneficial to us.
I like that.
Some of your thoughts there.
Well, yeah, I can give the Latin actually. Limbus, from which we get the word limbo, and the game limbo means boundary. And so it's almost like this was at the boundary line of our understanding, and that's why it has such a poor definition. And
it's possible that that's one explanation, and maybe that's correct. The other explanation, a lot of the structures in the brain are named solely based on their appearance. Their appearance in either in large gross scale, that is, you just imagine you pulling the brain out of an animal or a human and kind of dissecting it apart, or pulling and poking at it, and you see some differences. There could be gross differences. And so like hippocampus has a relationship to seahorse. And so that's it's only the shape of it that gives it its name. Sometimes they also do more detail. It could be microscope histology, that they look at other delineations about the cell types that you couldn't see just with the naked eye. But in any case, I like what you're thinking about that. It is possible that that description about using limbo, that's an interesting take on it.
Yeah, well, and okay, so I just wanted to ask you one question, because I think you said something, and I may have misinterpreted the Gray article on this, but I thought the better your habit is formed, the more you've put into it, the less a brain area activates when you embody the habit, and
I would agree with that.
Be that it remains dopaminergically sort of, what is the verb for that? Mitigated or agonized by?
Agonized. Well, we have to be careful. There's dopamine, but dopamine in which parts of the brain, and dopamine is being released by which cells, and being received by which cells. There's also different dopaminergic receptors of different types that have different functions. So I think the answer, so to your first part of the question, I think that's right. Dopamine, it's important. As we all know, we struggle when we learn something new, whether that's sensory motor related, or even just cognitively related. We struggle when we learn something new, and it takes more effort on our part. And that a lot of it is more cortically, there's more cortical circuitry involved in sort of inferring what's happening, monitoring our mental state or our motor state. But that's where the dopamine can be related to when you perform something, whether cognitively, mentally or physically, and it you mentioned goals earlier, and you achieve that goal, that has reward value. So the dopamine present in that situation is more likely to promote or crystallize the pathway that was just activated in order to give you that outcome. And once that's done, repeatedly, that circuitry becomes almost just imagine a chain. A connects to, or A activates B, which activates C, and that could be physically amongst groups of neurons or sequences of behaviors. And so, if you've learned it, you don't need that. It's easier to do, and there are therefore sort of especially less of the cortex is active in initiating or carrying out that process. And then the second part, sorry, I lost my train of thought. That was, you were asking about.
It's okay, because I actually have a response to your first one.
Okay. And then we'll get back to that, maybe.
As our literary example for today, Dante's Purgatorio, Canto 4, line 88. And this is, and actually I'll start at 85 just because of what goals are. Because what I want to offer in this, through these examples, is that some of these poets from the past were trying to represent to us phenomena that we would later come to study scientifically. They were trying to offer us real phenomena from the world in these storehouses. And so I think this will connect nicely to what we've been talking about.
Great.
And he to me, this mountain is such, I said I was going to start above that, but if it pleases you, I should like to know how far we have to go. For the hillside climbs higher than my eyes can follow it. And he to me, this mountain is such that the first part of the ascent is always hard. And the higher a man goes, the less hard it is. Therefore, when it becomes so agreeable that the ascent becomes as easy to you as movement to a boat that is going with the current, then you will be near the end of this path. There you may hope to rest from your exertion. I can tell you no more, but that I know for certain. And when he had finished what he had to say, a voice sounded near us. It may well be that before then you will want to sit down. All right, well, we don't need to go into that. That's Balakwa, a very lazy man. But basically, we laid out some notes here that sort of means that what the Purgatorio is, which is a place of burning away bad habits and inbuilding good habits in order to purify oneself with all that fire imagery, that the way starts hard but becomes easy. And that this was sort of a metaphor for any task or the development of skill. And so sort of a literary example of what we've been talking about, broadly scientifically. And then one earns one's rest by developing such skill that one's work is effortless. And so Dante's giving sort of a practical manual to the world, or to the working person in the world, to become as skillful as possible in as many situations as possible, in order to literally, actually not have to be as cortically active and pay as much attention, because one's skills are so effectively inbuilt that one effectively moves through life in a more effortless and less effortful fashion.
And so let me ask you, interrupt and ask a question about that. In the greater context of that poem and Dante's sort of 7 layers of this mountain, or 7 terraces of this mountain, is he intentionally talking about skills, efforts that go beyond just physical skills?
Yes. I mean, because this is his literary tour de force. And so he is suggesting that as he is writing this poem, he's improving, and he's going past other poets from the past. And he's using all his experiences and all his learning, because that is always what the underworld or afterlife represents in poetry, going through your own experiences and the literature that you have acquired in order to represent something new to the world that will, again, just be another storehouse for another consciousness to take treasure from at another point. And so the idea seems to be that what sin is for Dante is that which takes you off the path towards freeing your will. And so in the Purgatorio, you free your will by removing all these sins from yourself. And that seems to be like taking your will out of useless endeavors that suck your energy away, which strikes me as developing the skills necessary to be maximally adapted to your environment, whatever that is, so that your life becomes more effortless rather than effortful. And I don't know to what extent you could do that, because, very few lives are that ordered, and maybe that would drive us crazy. But
well, I think there's an interesting, I want to just maybe touch on this or ask you a side point about this, or make a connection, but maybe it's something where the analogy or the metaphor sort of breaks down. And that is that, in that description, knowing not much about that poem besides what you just described, it seems as if there's almost one path. There's only really one path, and it's upward, right? So you keep working on skills, a set of skills, and you will ascend, right? And things will get easier. But there is a counterpoint to that, which is that in terms of when we go back to the neuroscience and especially the motor, it's often easiest to give the motor example, and in which you develop a skill, and it takes you far in one endeavor. But when you learn a habit or a skill that is sort of mindless in the sense that you're not using as much cortical resources to pay attention to what you're doing, it is much harder to break that habit if you need to do something different. And so again, it may be easiest to think about it in in the motor system or in sports. So perhaps someone becomes very talented or skillful at tennis, but then they switch to, or when they want to play a different racket sport, say racquetball or squash, maybe they'll be really good, but not at, it's very difficult for them to be as good at that because they need to take different movements, or in a sense have different behaviors. And they're so ensconced in their tennis movements that they really can't break that habit. And, one thing I want to keep bringing up or connect in this whole discussion is, and this isn't known, but to what degree do we have sort of cognitive habits that
Right.
we've learned through the years, and maybe they served us well, and they were really, especially younger, they served us well. But at what point do they actually become a burden because it makes us jump to conclusions in a way we may not even be aware that some of our thought processes are so-called habits.
Right.
And without that awareness, even with that awareness, it may still be hard to break those habits, be they motor or cognitive.
That's right. And we certainly have cognitive bad habits. That's
right.
For sure. And that's interesting because that makes me really think about the fact that we just got a notification of 10 minutes, and that just popped up right in my face when
I see that.
A little amygdala hit.
We can jam a lot in 10 minutes.
Yeah. And so let's see. Where were we? Okay, so sorry, I wanted to hit that point. What was that last bit again? Sorry, that really got me. I was so focused in on what you were saying.
Just about the, we can form bad habits, or they may not necessarily even be bad. They just may be targeted towards certain goals, certain values. Go back to the dopamine representing value. There was something that gave it that value, and so it became a habit. And though, as the saying goes, a habit's hard to break. And maybe we've talked many times in past sessions or past podcasts about various types of cognitive biases, and maybe some of those are sort of wrapped up in this same notion, or they're related. Those biases may be in some ways mental shortcuts, and those worked out. Those were sort of like cognitive skills that we developed, but they can lead us astray as well.
And so I remembered what I wanted to say, and it was that relates to, I would say, my major interest, which is personality transformation and how that can be done in an actual neural and physical way. And that changing your bad habits from a more youthful time of life that were good adaptations then that are now maladaptations at this current time.
Yeah, sorry. And that triggered, you asked 10 minutes ago about the limbic system, but also how it relates to young people and their sort of slower, longer, cortex takes longer to develop and mature, especially the frontal cortex versus other parts of the brain. So, yeah, sorry, I interrupted there, but we can touch on that as well.
Go ahead, please do. I just wanted to make sure I said that and didn't forget it again.
Yeah. Well, you brought it up initially, and I'm not sure I have a lot to add to it, but other than to say that's a fact that it's well known that your subcortical areas develop earlier, and it takes longer for the surrounding cerebral cortex to develop, and that's especially true for the frontal lobe, which is most responsible for our sort of deliberate thinking, executive decisions, and executive control. That is inhibition of our sort of telling our subcortical or not taking the emotional knee-jerk responses that our emotional system might drive us towards, not being able to sort of inhibit some of those responses. So this is a very much explains at sort of a high level why younger people, even well into the adolescent, can be sort of very capricious and driven and by their emotions. Of course, many older adults are too, but there is a time course through life that that is well known, where as you become older, and especially as you hit maybe your early 20s and even a little bit later, finally things are sort of I won't say they're done, but they're done developing in the traditional sense. but beyond that, it may be sort of more in the area that you were just about to broach, which is how can you change your personality? Some people would, if some people claim that can't really be changed. There are some recent studies that show that, just like I described, over the course of time, people's personalities do change in certain ways. But we all go through growth stages, and some of those are purely developmental in the sense that there's literally growth of neurons and other parts of the brain. But then some of it is more your experiences and your own internal state of knowledge of awareness, and that's the rest of life, the next 40 or 60 years, hopefully.
Yeah, well, just to parse that out a little, there are certain motivated states, like we were just talking about from Panksepp, that do come into existence at different times of your life, right? Like, say, like your motivation to mate. You don't really have that so much until you can. And the other motivated states, it's just that it seems as if, since different parts of your brain continue to grow at different rates, that the habits you develop in the absence of your executive function are certainly going to be suboptimal and will require your executive function to parse back through them in order to optimize them, because they have, unless you've been, really well coached and really, really well parented and taught, right? And you have like only good habits, which would be very useful. But I feel like that would be like, say, a neuroscientist's way of being a psychologist, right?
Mm-hmm.
Like, what are the action patterns you developed? What are the goals they're related to? How have you, where's, it's like an engineer. Where's the delay in the circuitry? Where's the issue here? Are you setting the wrong goals? Do you still have primitive ways of going about doing things? Do you still want things that a child would want that maybe are not in your best interest now? And so, yeah. Well, what did you think about that? Sorry.
Well, I thought the whole, even from just a purely neuroscience standpoint, I was really intrigued, and I'm not too familiar with these studies, but the Yaka Panksepp's studies, but it was really interesting. He to reiterate what you said, he proposes or puts forth sort of 7 fundamental states of emotion or motivation. And I just have them listed here, so I'll just read them up. But play, panic, and grief, which are sort of 1. Fear, rage, seeking, lust, and care. Probably most listeners will know what all those things mean. Seeking, to be clear, is more about the curiosity and enthusiasm. So if you're seeking, you're excited, or you're energized to move about your world and understand it, or explore yourself too. Could be internal and internal reflection. But that was found, there's studies of evidence of all this in rats, and rats are like us in the sense that they have all those same major brain areas. But I thought what was even more interesting is that there's studies in birds too, where they find a lot of this. And birds are quite different, but they have analogies, I'd say, or parallel circuitry. They don't have any cortex, but they're, our subcortex, it can be compared to their brain. So even without that cortex, they have all these. So that's great. But then you're going towards, or asking about, commenting about the fact that, we have the cortex. When does that executive control come into play? How can people, through the course of their life, sort of better integrate, I guess, their executive function with these lower emotions, which are great, right? I mean, it's emotions that sort of give us pleasure in life, not just the pleasure like we were talking about before with opioids, but just the pleasure of art and knowledge and interaction with people. And I think part of this is, I guess the only thing I wanted to say about it from sort of the neuroscience standpoint, beyond what we just discussed, is that, humans evolved to be a very a social animal, highly social animal, and those social interactions are quite complex.
Yes.
And so we probably developed part of the reason we may have developed such a large cortex is in order to navigate those social complexities.
Yes.
And some of that complexity required having greater control over our emotional underlying states.
Well, I think I would essentially make the claim that the 7 motivational states are the original sort of polytheistic pantheon of gods.
Oh, I like it.
Like Aphrodite is lust, and like seeking mating behavior. Aries is like offensive aggression. Apollo might be very well defensive aggression, or the birth of consciousness or cortex and its ability to lead. Zeus is sort of the order of society that you have to, that the ordering principle that subjects the motivational states to a greater system than their petty desires. And this guy Peterson, who's a clinical psychologist, claims that that's what Piaget calls an equilibrated state, where you sort of take account of the of who you are and what you are, and then you sort of develop a way to make yourself pleased or satisfied in all those ways. So you satisfy your need for whatever your need is for, say, aggression or seeking or whatever it is, and you
have to balance your needs amongst all the possibilities, right. And it's custom to the individual. Is that part of it?
Right. And the psychologist would say that something like a neurosis or some sort of issue will arise when two of them are at war with each other. So you're engaging in two action patterns or habits that make two of these motivational systems collide. That causes extensive emotional distress, because it's a systemic issue with. Right. So I was saying, until Zoom kicked us off, and so we're starting this one again, that it's sort of a systemic issue. When two motivational states or two actions which are used by the motivational states in order to get what they want come into conflict, and both are prevented from getting what they want, that is sort of akin to a war of the gods, a theomachy. That means that your state is disequilibrated in time, which means that you, as sort of the conscious hero, Marduk, or the sort of Jesus figure, or Apollo, the bringer of light, must go down into that situation and fix it by setting the motivation straight, and by setting the action patterns straight that are crossing each other's path. Like, for instance, if, say, you want to pursue mating and you want to get a wife, but you're socially anxious and you refuse to go outside, and so your anxiety but your desire for companionship are going to be at odds with each other, your care circuitry. And so you're going to have to parse that out by use of your executive function, because you can do that just by changing the habits or the action patterns or that which you have built neurologically into your brain. But I say but that's obviously very hard and takes a lot of time. But you can actually do that.
I like it. This is a fun analogy. I feel like I need to see some cartoon panels too to describe it. But
yeah, for sure.
Yeah, but it's great. Really, really good thinking. And is there thought? So you've already sort of described where one emotion can conflict with another, and to the negative of the behavior of the organism, potentially.
Right.
And it may be that even, however, I could imagine where there's just one alone. If the other ones are inactive, one alone can drive some very negative behavior. So it may also be a question of extremes, right? And so I don't know if sure you could come up with some God's analogy or something from mythology where,
oh yeah. Well,
one of them, it's not even just that others have relinquished control. It's that one is fully in control, and there is no sort of executive function, however that may be represented, to at least turn down the game, turn down the activity of that one primal emotion or that particular mythological character.
Yeah, well, the one that gets it worse in the Greek pantheon, at least in the Iliad, is Ares. He's the god of conflict and violence. He's actually described, when he's first described in Book 5, as bloodstained, stormer of strong walls, and manslaughtering. He gets 3 epithets because he's a god, and most people get like 1.
Lucky to be a god.
Lucky to be a god, and lucky to be Zeus' son, because he does get stabbed by a mortal, and Zeus says, "Talk to me not, you two-faced liar. To me, you are the most hateful of all the gods," which is exactly what Agamemnon the king had said to Achilles, his greatest warrior, in Book 1. And so who Zeus, the principle of order, hates, is Ares, the principle of conflict. And so I wonder if that's aggression, sort of, or anger and rage circuitry, that it can get out of hand pretty quickly. I mean, rage is literally the first word of Western literature. Manen means rage or wrath in the accusative of Greek. And that's the first word of the Iliad. So I would say that it gets a bad rap in literature.
Doesn't, and I could be way off, and so it's Ares, not Eros. I'm thinking of like how there are two forms of love, agape, which I believe is sort of like brotherly love, and maybe it's Eros, not Ares. That is sort of our traditional view of procreative love.
Yes, Eros is represented as that Cupid figure. Yes, that cupidity, that sort of desirous, potentially even to an extreme lustful feeling for someone. That's right. And he's traditionally the son of Aphrodite and Zeus. And
right. So different Ares. Ares, not Eros, to be clear.
Right. Ares, god of war, not Eros, god of love. Right. All right. Well, I think we hit a lot of good pieces today. We didn't get as much into motivated reasoning and a type of cognitive bias today, but maybe
we have plenty of opportunities. So I think that's sort of one of the underlying themes of this series of podcasts. So we can always come back to that. Yeah.
Well, I'm looking forward to it. We've got plenty more material to discuss and plenty more about have we finished learning about the brain yet, Doctor?
If we should probably report that to the rest of the neuroscience community, because they're working very hard at that.
All right, good. Well, then there's plenty left to learn, and I'm really looking forward to the next conversation and delving even deeper in.
Likewise, Alex. It's been great.
All right. Well, until next time.
Catch you then.
The podcast you just heard was published with Anchor. Got something you want to say to the creator of this show? Send them a voice message using the Anchor app, free for iOS and Android.